Hello students, today we are going to discuss the chemical properties of carboxylic acids. Last class already discussed the preparation of carboxylic acid. So what are the properties of carboxylic, mainly chemical properties we will discuss. If you see physical property of carboxylic acid, that it is water soluble. All carboxylic water soluble because they form intermolecular hydrogen bonding with water. That's why it is water soluble. Then it has also high boiling point. That means acid has boiling point greater than alcohol, because generally acids, due to strong hydrogen bonding, exist in dimeric forms. Acid exists in dimeric forms. If you draw the structure, that this is an acid structure. Here are so this dimeric hydrogen bonding takes place. Dimeric form due to hydrogen bonding, intermolecular hydrogen bonding. So molar mass increases. That's why boiling point increases. Generally, this dimeric form of acid is mainly possible in case of nonpolar solvent. In aprotic solvent, aprotic solvent means that having no, that it does not produce H plus ion. So if you take this type of solvent, that is your benzene like this, then acetic acid, benzoic acid, they produce dimeric form. That's why molar mass increases, becomes double. That's why it has boiling point increases. So water soluble, high boiling point compared to alcohol. Then very important properties, if you take acid reacts with sodium metal, reactive metal, produce salt and hydrogen gas. This is very important reaction of carboxylic acid. And acid also reacts with base, producing salt and water. This acid reacts with sodium carbonate and bicarbonate, reacts with sodium carbonate or bicarbonate or carbonate, forming which gas? CO2 gas, very important, plus salt. Very important thing is when carboxylic acid reacts with bicarbonate or carbonate, always produce carbonate gas. This is very important, that test to identify the salt is carbonate or bicarbonate. So this reaction is very important also. Then acid reacts with base and reactive metals like this. Then carboxylic acid reacts with, this undergo substitution reaction with PCl5, forming acid halide. This is acid chloride, acid halide. This is acid halide, acid chloride, and result is POCl3 and HCl. Acid reacts with PCl3, forming same acid halide plus H3PO3. You remember, this is the difference between that PCl5 and PCl3. Acid reacts with SOCl2 like your alcohol, forming here corresponding acid halide and sulfur dioxide, and here HCl. So this reaction is also a very important reaction in the preparation of pure acid halide. Pure acid halide can be prepared by this method, thionyl chloride. So this is the one important reaction of that substitution reaction of what? Halogen substitution of which one? Acid group. In place of which halogen is substituted. So this reaction is called halogenation also. So acid this. Then acid, when salt of acid undergo that electrolysis produce alkane, and your remaining is that carbon dioxide gas and sodium hydroxide and hydrogen. This is very important reaction, and this alkane is produced where? Anode. There is one question, because if you see CO minus and Na plus, so during electrolysis this anion goes to cathode. It goes to anode. Anion goes to anode, and so it undergo formation of alkane. 2R will combine and CO2 is removed. And here hydrogen gas produced at the cathode. This is very important. This reaction is called Coles electrolysis. The name reaction, Coles electrolysis. Write down, this is very important. Name reaction, Coles electrolysis. Then decarboxylation reaction, if you take acid, sodium salt of acid, if you heat soda lime, in presence of soda lime and heat is produced, that RH alkane, produce alkane and sodium carbonate, and this reaction is called decarboxylation. You have read in class 10. Decarboxylation reaction, that is preparation of alkane. In class 11 also, in preparation of alkane chapter, you have read when sodium salt of acid undergo, that is when decarboxylated in presence of sodium oxide and calcium oxide. What is the role of calcium oxide? It helps to fuse the mixture of salt and sodium hydroxide, and so that the amount of alkane will be more. This reaction is called decarboxylation, loss of CO2. That is called decarboxylation reaction. So Coles reaction, decarboxylation. Then acid, when reacts with ammonia or ammonia derivative, then first it produces salt. Salt is produced. When this salt undergo on heating, produce acid amide and water. This is acid amide. This is acid halides. All are acid halides. So these are acid halide, acid amide. These are the derivative of acids. Then same acids, when reacts with P2O5, which acts as a dehydrating agent, on heating produce acid anhydride plus water. Here are two molecules required. This is acid anhydride. So preparation of acid anhydride, acid amide, acid halide. Then like this, what are the other reactions? Formation of salt, that is formation of ester, when acid reacts with alcohol. Already we have discussed in alcohol chapter, this mechanism already we have discussed. In presence of sulfuric acid acts as a catalyst, result is ester plus water. This reaction is called what? Esterification. This is called esterification. This is called esterification already. So acid halide, acid amide, acid anhydride, ester, these are derivative of acids, carboxylic acids. So they can be prepared from acids. Then acids, when acid containing alpha hydrogen atom. When acid reacts with acid containing alpha hydrogen reacts with phosphorus and halogen, it produces RCHX, then acid. This alpha, that is in alpha position, halogen will be substituted. Only alpha position. So this reaction is called HVZ reaction. HVZ reaction. HVZ reaction means Hall-Vallard-Zelinsky reaction, HVZ reaction, formation of halogen derivative of acids at alpha position. So this is called Hall-Vallard-Zelinsky reaction. We know that when acid derivative are COO and its salt, calcium salt of acid derivative when undergo dry distill when heated result is ketone plus calcium carbonate. Ketone is formed. But you can prepare aldehyde if you use calcium salt of acid with formaldehyde. If you take calcium salt of NaCl with calcium formate on heating, result is aldehyde. Plus calcium carbonate. So this reaction is very important to prepare aldehyde and ketone from acid. You have to take acid, calcium salt of acid, then when it undergo dry distillation, it produces ketone or aldehyde. But when you take a mixture of this, when you are using calcium formate, the result is always aldehyde. Without calcium formate, if you heat the calcium salt of acid, you will get ketone. So this is the important method of preparation of aldehyde and ketone from acids. Then aromatic, if you see, then if you reduce the acids, when acid undergo reduction in presence of lithium aluminum hydride, then produce alcohol. Already we have discussed in alcohol chapter. From acid we can prepare alcohol by what? Reduction. So preparation of alcohol from acid. As aromatic acid, this carboxyl group is a electron withdrawing group. This is electron withdrawing group. As it is an electron withdrawing group, so electron density of the benzene decreases. That's why this benzoic acid is less reactive than benzene. Less reactive than benzene due to less electron density in the ring due to electron withdrawing group of carboxyl group. So if you see the resonance, so positive charge is produced here. Then next step positive charge here. So ortho para position getting more positive charge. That's why if you take any electrophile, so it will attack at meta position. So generally benzoic acid and its derivative produce meta substituted electrophilic substitution reaction. Mainly at meta position, because ortho position and para position getting more positive charge due to resonance. Because carboxyl group is the electron withdrawing group, it deactivates the ring, so positive charge is more in ortho para position compared to meta. That's why electrophile prefer to attack at meta position. So it always produce meta substituted product. What are the electrophile substitution? Already you know these things. That benzoic acid, if you take, this is your benzoic acid, and if you do sulfonation, product will be like this. SO3H, already we have read. If you do nitration, product will be meta substituted product. Nitration. Halogenation, if you undergo halogenation, that chlorine, if you do substitute X2, the product will be then chlorine. This can be done that I prefer in aqueous medium. This product will be meta substituted product. But this reaction, generally alkylation and sulfonation, if you do RX and aluminum chloride, here RCOX and aluminum chloride, no reaction takes place. It is very important because carboxyl benzoic acid contain carboxyl group. This carboxyl group reacts with the Lewis acid, aluminum chloride. Generally, aluminum chloride acts as a Lewis acid. It helps to produce electrophile. But before that, benzoic acid reacts with aluminum chloride, forming the salt. That's why the reaction will not take place. Friedel-Crafts acylation, or Friedel-Crafts alkylation, both will not take place, which is not shown by benzoic acid due to the formation of salt with Lewis acid, aluminum chloride and benzoic acid. That's why these two reactions is not shown. So this is about the some electrophilic substitution reaction of benzoic acid. Then we will discuss now the acidic nature. Acidic nature. We know acidic nature mainly depends upon that electron withdrawing group increases. Acidic nature and electron donating group decreases. Acidic nature. These are two concepts already we have read. So if you see formic acid is more acidic than acetic acid. More acidic character means lower pK value, already you know. So formic acid is more acidic than acetic acid because acetic acid has plus I effect. As acetic acid is more acidic, this is acidic nature. Acidic nature, but formic acid has low pK value. This is the pK value. If you compare the pK value, more acidic, low pK. More acidic, low pK. This is very important. pK minus log. This is called minus log K. This is pK. So higher acidic, higher K, but lower pK. So benzoic acid, if you compare, formic acid is greater than, but the order is formic acid greater than benzoic acid. Benzoic is greater than acetic acid. This is the order, acidic character. But if you see substituted, if you substitute that acetic acid plus acetic acid, if you write, it is more acetic acid than acetic acid. This is due to minus I effect. Due to minus I effect. Minus I effect, electron withdrawing group, that is minus I effect. Minus I effect, electron donating group, that is plus I effect. This is very important. So minus I effect increases acidic character. That's why chloroacetic acid is more acidic than acetic acid. So this is very important, that the concept minus I effect and plus I effect. But if you see benzoic acid, what happens? Benzoic acid has different types of benzoic acid. You can suppose you give the substitution of benzoic acid, that is your toluic acid, orthotoluic acid, then metatoluic acid. If you see metatoluic acid, then paratoluic acid. If you see the order of acidic character, this one greater than this one, because here what happens, due to ortho effect, this is called ortho effect. Ortho effect. Due to ortho effect, what happens, the benzoic acid, the carboxyl group will not remain in coplanar with the benzene ring. That's why due to this what happens, the loss of H plus can be easily done. So due to this, due to ortho effect, what is the here ortho effect? Ortho effect means what happens, due to the repulsion, bulky group of methyl group, due to the repulsion, benzoic acid and methyl group undergo repulsion. Due to the steric hindrance, due to steric repulsion, carboxyl group will not remain coplanar with the benzene ring. That's why H plus can easily be removed. That's why orthotoluic acid is greater than meta than para. Here what happens? Here what happens? The electron density of the towards the ring increases due to here plus an effect, and another is plus M, that is hyperconjugation. So hyperconjugation is more effective here, and mine plus I effect also more effective. So if you see the electron density towards the ring increases, that's why it is least acidic. But here exception, due to ortho effect, as it is not coplanar, it cannot remain coplanar with the ring. Which one? Carboxyl group. That's why loss of H plus ion will be easier. That's why it is more acidic. But similarly, if you see nitrophenol, nitrobenzoic acid, same. If you do that nitro group, if you place here, then which will come para, then para nitro, then meta. These were somewhat exception. Here same ortho effect. This is also ortho effect. Not ortho effect. Due to this ortho effect, these two group, what happens? The acidic character will be more, because after loss of H plus ion, then what happens? This nitro group. In case of benzoic acid, whether it is a plus effect or minus effect, both case acidic character is more due to ortho effect. Due to ortho effect, acidic character of benzoic acid increases in both cases, maybe plus effect or minus effect. So this is regarding the acidic comparison of acidic character minus I effect of the benzoic acid and its derivative and its acidic character. So this is regarding some important characteristic of benzoic acid and its derivative. So all carboxylic acid has a common group, that is COH group, all having COOH, this group. And this group is called carboxylic acid, carboxyl group. And this carboxyl group, either it take part involvement of OH group, OH bond involved, or CO bond is involved. But this carboxylic acid does not show the test. It does not show test like aldehyde and ketone. Aldehyde or ketone. Aldehyde group already know. Aldehyde have same carbonyl group. Ketone having same carbonyl group. But this reaction is not shown by acetic acid because due to resonance. Already I have told you, due to resonance this double bond character of acid breaks. That's why it does not show nucleophilic addition reaction unlike aldehyde and ketone. Aldehyde ketone shows nucleophilic addition reaction, but acid does not show due to resonance. Double bond breaks due to resonance. So this is about some important comparison of carboxylic acid and its characteristics. So next class we will discuss regarding the test of carboxylic group, carboxylic acids, and how it is differ from the phenol in the next class. Okay, thank you all.